I, Dr. Karuna Segul, Department of Computer Science, SGBIT, Belgavi. Would like to continue with the program 3. Right? The program 3 of the C programming lab. Program to compute quadratic equation by accepting the coefficients. Print the appropriate messages. So in this case, we need to know the formula to find the roots of a quadratic equation. So this is must for us. So I hope we already know about the roots of how do we find the roots of a quadratic equation. On that basis, we'll try to find the we'll try to write the equation, program for the same thing. So before I proceed, so let me write the equations, then we'll proceed with the same thing. So I'll write x1 or x2 as a root of a quadratic equation is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, where a, b, c are the coefficients of the quadratic equation, given quadratic equation, right? We are supposed to find the value of x1 and x2 here. So what kind of a roots you are going to get for this? It purely depends on b square minus 4ac in this case. So that's why we are first finding the value of this b square minus 4ac as a discriminant. So depending on a discriminant value, we are able to tell what kind of roots we are going to get for x1 and x2 there. So meaning of that is very simple over here. If I write it as discriminant, okay, that is b square minus 4ac. If this d is equal to 0, then I say that the roots are equivalent. Roots are equal and distinct. What we call it as real. If I go ahead with d greater than 0, so this shows me that the roots are equal and roots are distinct and real there. Okay, so here it is real and equal. So in this case, real and distinct. So if d is less than 0, so this tells us the roots are imaginary. So we need to find the real and the imaginary part of this particular root before we display it on the screen. So this is a base that is required for finding the roots of a quadratic equation. So let's proceed with the algorithm of the same thing. And the algorithm purely depends on whatever we have discussed just now. Okay, so now before we proceed with, so we need to take care of certain conditions there. Okay, so if we have the coefficient a existing, then only we say it is a quadratic equation. If a is not existing there, then there is, it's not a quadratic equation. So there is no need to find the solution for that particular, or the what we call it as the roots of a particular equation there. Because it's not a quadratic equation, so there is no question of finding the roots of that. So we are going to read now, it's an algorithm that we are beginning with. Read the coefficients as a, b, c over here. Okay, then check the validity of that. Okay, so if a is equal to 0 or b is equal to 0, then I say that we are unable to find the roots of that, and we are exiting from the program. Okay, if we have all the coefficients intact there, then we'll try to find out the discriminant value. I already mentioned discriminant value is equal to b square minus 4ac. I have written the c expression for the same thing now. Once we get the discriminant there, based on the discriminant value, we are able to find the possible roots, and we are able to print the same thing that we have calculated there. If discriminant value is 0, then the roots are real and equal, and therefore we are checking for the same thing. If discriminant is equal to 0, then roots, because the discriminant part of the equation is 0 there, so I'll get only minus by 2a there, minus b by 2a there. So that's what I have written here. So try to place this inside the braces. Okay, so that will take care whenever we write the program. But this is a simple equation that we are supposed to write for this, right? Because these two will be multiplied first, then it will be, okay, so then b will be divided by the multiplication of 2 and a there. Okay, and we know that r1 is equal to r2 there, so that's why we are placing the r2 into r1, because the roots are equal there and we are printing the same thing here. Next, if the discriminant is greater than 0, then the roots are real, but they are different, right? So distinct. So that's what we are mentioning here. We have the positive value for this d value. We are finding the square root of that. Okay. Then after finding the square root of that, okay, 1 plus value and 1 minus value is going to talk about the, what we call it as the roots of a quadratic equation. For one, we'll be taking plus value. For another root, we'll be taking it as a minus value here. So r1 is equal to minus b plus square root of d whole divided by into bracket 2 into a. Okay, so if you go ahead with r2 there, only sign is changed there, minus b minus square root of d whole divided by into bracket 2 into a bracket close there. Right, so these are the real roots and distinct roots that we, real and distinct roots that we got for the quadratic equation when the discriminant is greater than 0. Next case is the else part of this, you already know the discriminant value is less than 0. So less than 0 tells us that, okay, the square root, the value under the square root is minus value there. So we will be getting the imaginary values for that. So that's why we are interested to find the real part and the imaginary part separately, and whenever we display the results there, we'll be combining those things and we'll be displaying it. So Rp is equal to the minus b divided by 2 into a, whereas Ip is equal to square root of, because as d is minus here, I need to take an absolute value of that before I place it or find the square root of that particular number there. So square root of fabs of d divided by 2 into a. So it's going to give me only the imaginary part there, right? Okay, then what I'm going to do, so it's my duty to print these values are the roots, in a right manner. So imaginary roots. Okay, we already know if discriminant is less than 0, we got the imaginary roots there. Therefore, I'll be writing the root 1 as the real part plus I'll be writing I just to represent the other part of this is the imaginary part, right? So IP is the imaginary part that I have calculated here, and next we have something called as R2 is equal to RP minus. Okay, so now this is the only difference between the R1 and the R2 value. Okay, so RP and real part and imaginary part is for us. So this is about the, okay, the algorithm that is helping the roots of a quadratic equation. So once we know about this, let's proceed with the program. I'll be using the input-output statement for that. Okay, stdlib because I'll be using the exit 0 for it, and math.h because I'm using a square root function there. So I'll begin with the program there. Okay, so I have so many variables that I have taken care here. A, B, C, D, I have declared it as int there. So floating point values are root 1, root 2, imaginary part and a real part here. Then I'm asking you people to read the coefficients of the quadratic equation there. So we are reading the same thing using a scanf statement there. Okay, so these are the coefficients of the quadratic equation there. Once we read that, then what we'll check? I'll check for the, okay, so instead of this, if you use piping also, that is R also, that is also fine with us. Okay, because sometimes if B is read as 0, then if A is existing there, still we people are able to find the roots of a equation there. So better use OR operation rather than the AND operation there. Okay, okay, so A is equal to 0 or B is equal to 0. Okay, then we don't have the right coefficients there, right? So that's why what we are going to do here, So we are just printing it as the invalid inputs there, and we are going to come out of the program there. So exit 0 is corresponding with the what we call it as the standard library.h there. If you don't include, you are unable to use this particular exit 0 there. Okay, so now if whatever coefficient that we have read here all are valid there, then we'll go ahead with calculation of what we call it as a discriminant there. How do we calculate discriminant? The equation for discriminant is b square minus 4ac. So this is a C expression that we have written for the calculation of the discriminant there. Once we calculate this, so depending on a discriminant value, we'll be taking or will be calculating the roots of a given quadratic equation there. So discriminant value is 0. Okay, if it is 0, then what I am going to do? Because you already know the roots are real and equal there. So we'll try to find the same thing. The discriminant part becomes 0 there. We don't have anything under the square root of the roots there. Then we'll have only minus b divided by 2a left out there. So that I am going to calculate, and I am going to place that inside the root 1 there. And so once I get this, I'll try to place the same thing inside the root 2 also. Right? Okay. So in this case, if you look at this minus b, okay, and a, both are integer that we have considered. Okay, but we know that the roots can be the what we call it as the floating point value. So you people can also forcibly convert this into the what we call it as the floating point value there. To do that, we go ahead with the external typecasting, right? So how do I do that? So I'll simply write it as float into bracket minus b. I'm converting b into floating point value before I go ahead with the division operation. Okay, because so this is also integer, this is also integer. If you go ahead with integer division, I am expecting or I am getting only integer division there. So I'll be getting a pure or the integer quotient there, but I'm not interested in the what we call it as the integer quotient there. I'm interested in the floating point value there. That's why I'll convert any one of these two values. Any one of these two value will be forcibly be converted into floating point value before I proceed with the division. So that's what I have done here. So float minus b divided by 2a. Okay, so this is converted into float before we proceed with the division. Right, so if this is float converted into float automatically, so 2a, whatever result I am going to get out of this, that is also converted to float, okay, implicitly by the compiler before we proceed with the division operation there. So float is divided by a floating point value. I am expecting the result as a floating point value, and it is stored inside the root 1. Root 1 is also already declared as a floating point value there. Okay, this is the best method that you people can proceed with, right? Okay, so root 1 is placed inside the root 2 there, and I am displaying the same thing. Roots are real and equal there, and roots I am displaying only 2 digits after a decimal point. Okay, and this is my root 1 and this is my root 2. So that's why I am printing here root 1 and root 2 in this case. So let's proceed with the next bit. Okay, so if is done now, so I'll take care of d may be greater than 0. Else if, I'll write it as else if d is greater than 0. And I know that the roots are real and distinct and different there. So in that case, I'll be proceeding with this. Okay, so now if you look at this minus b plus square root of d. Alright, so square root of d means, so I'm going to find the, I'm having the discriminant that is already calculated. I'm finding the square root of that. That will be subtracted with minus b, or subtracted with this b value. Okay, whatever result that I got here, I know it is the floating point value because the square root of any integer may be a floating point value. So I am expecting this result to be a floating point value. If this is floating point value, if I divide this by an integer, so that whatever result I can expect there, it is also a floating point value there. Right? Okay, so only difference between these two is here it is plus, here it is minus. Right? So only that is a difference between root 1 and root 2. So whatever square root value that I am going to get here, so that will be for plus first added with the minus b there. In the second case, whatever square root of a discriminant that I am going to calculate here, that will be subtracted from the minus b there. Okay, so whatever result I am going to get here, that will be divided by 2a. Okay, and the same thing is true for this second case also, and I am going to get the results for the root 1 and root 2 there. I am going to display the same thing. The roots are real and distinct here. Okay, printf root 1 is equal to, again I am displaying only 2 digits after decimal point for root 2. Okay, so the same thing is true for this also. I am displaying root 1 and root 2 for these two percentage f's. Okay, so this is if the discriminant is greater than 0. Okay, the last case is else part of it. It tells me that the discriminant value is lesser than 0, right? So I'll be expecting the imaginary roots over here. To get the imaginary roots, okay, so I have to calculate the real part separately and imaginary part separately. How do I do that? So I'll take care of the square root data separately and the real part separately. Okay, so now if you look at this, real part is equal to float. I am explicitly converting this into the floating point value before I proceed with the division operation, right? So float b is converted into floating point value before I divide this by 2a, right? So imaginary part, so it is already in the what we call it as floating point value. No need of converting it into a floating point value here. Square root of fabs, right? So it is, this is minus value, right? So I cannot find the square root of a minus value there. So that's why I'm converting that into absolute value, right? So before I go ahead with finding the square root of this d, right? So d is converted into a plus value before I proceed with the finding the square root of a given number there, or given discriminant there, right? Okay, then it is divided by 2a. So I got the real part separately, imaginary part separately. So I have to take care of printing of this, okay, whenever I print the roots of a given equation. I know that root 1 is equal to, okay, so real part plus I imaginary part, right? So the same thing is true for the root 2 also, real part minus I into IP there, right? Okay, so I got the real part, I got the imaginary part, only I have to take care of printing of the same thing here. So I'll do the same thing now. So roots are imaginary, root 1 is equal to, okay, so first this corresponds to imaginary, sorry, real part, and this is an imaginary part over here, and root 2, again it is real part and it is the imaginary part over here. So real part, imaginary part, real part, imaginary part. I'll be writing it 4 times because I have used the formats 4 times, the format specifiers inside the double quotes of the printf statement there. Okay, so I have done with my work here. Okay, so I have calculated the roots considering all the cases of the discriminant there, right? So once we do that, so I'll be returning 0 because I have started with int main there and I'm closing the main brace here. So this is the end of the main brace here, right? Okay. So once we are done with this, okay, so I can show you some of the sample outputs for this. Okay, let's look into this. I've entered something like enter the value of ABC, okay, the coefficients of the quadratic equation. I have entered it as 1 to 1. So according to that, I have the discriminant value as 0 here. If you check it out, so you'll be getting the same thing. This is B, okay, this is A, and this is C here. Okay, B square minus 4AC is yielding me 0 here, right? If it is 0, then I am expecting it as a real and the equal roots, right? So that is minus B by 2A. So this is what I am expecting there, right? Okay. So next, another example that I have taken here. Okay, so ABC as 1, 3 and 1 here. Okay, so here you have the discriminant, but it is a discriminant is a positive value there, right? If it is positive value there, then you have to find the square root of that and it will be either subtracted from the minus B or added with the minus B there to get the final result. Okay, I mean after dividing that particular stuff by 2a, we'll be getting the roots over there. That's what we are getting here, right? So root 1 and root 2. And as it is, you have a d greater than 0. So please remember you have the real roots and a distinct or a different roots for the quadratic equation there. Next, ABC, again it is asking me to read the coefficients there. I'm reading the coefficients here. So in this case, minus, if you calculate the discriminant there, discriminant is less than 0 there. Okay, so I'll say it's a minus value there. So in that case, okay, so now I'm going to get the imaginary roots for it, right? Okay, then how do I calculate that? So root 1 is equal to, I'll be calculating the imaginary part separately, the real part separately, right? So then that's what we have done here. Only change is this is plus here, okay, this is minus here. The other parts remains as it is. This is real part, this is the imaginary part, this is real part, and this is imaginary part here, right? Only displaying of that is mattering for us, right? Okay. So next, okay. So this is all about the, what we call it as, finding the roots of the quadratic equation. Okay, thank you so much.